I'm just so. It helps.
Okay, guys. The question was about the area of 19 and 20. Okay? And they fall into the same section, but yet they work differently. And on 19, the directions are divide and simplify. My recommendation on the first step is always to try and divide them out. Okay? Always to try and divide them out. So, what I want to know here is, does anything divide? In other words, can I divide this? Does this fraction simplify?
Are you asking me?
I'm asking anybody. In other words, does 40 divide by 5?
Yeah.
Does x to the 16th divide by x? Yes? So my recommendation is always that we start off there, in that 40, square root of 40 divides by square root of 5. Since they're both square roots, we can divide them. Square root of 40 divided by square root of 5 is going to be square root of 8. Because 40 was on top and is bigger than 8 is on top. X to the 16th divided by x. How do we divide x to the 16th divided by x? Subtract. They're both under square roots, right? That's why we can do this. X to the 16th divided by x. 16 minus 1 is going to be x to the 15th. More x's on top. Since there were more x's on top, again, this works. Okay? Now, from here, we no longer have a fraction. So at this point, it just turns back into, how can I simplify square root of 8x to the 15th? Okay? What do we know about square root of 8? Does it have any perfect squares in it? Divides by 4 off of our blue paper, right? So I can rewrite this as 8 is 4 times 2. What about x to the 15th? How do we do perfect squares of exponents? Even number, right? So closest even number, closest number that divides by 2 below 15 is going to be 14. So we're going to have x to the 14th and leftover x to the 1st. All my pieces are still there, and it's cleanup time. The square root of 4 is 2. That's going to go out front. The square root of 2, can't do it, so it's going to stay square root of 2. It's going to stay under the square root. Square root of x to the 14th. How do we do square root of an exponent again?
It's just x divided 7 by 2, or x to 7.
Yeah. 14 divided by 2, since it's a square root, so x to the 7th, which puts it outside. And square root of x to the 1st? Can't do it, so that's just going to be x to the 1st. So we end up with 2x to the 7th outside, square root of 2x underneath the radical. Okay? So that's when your radicals can divide. That makes life a lot easier, right? That makes a much easier problem. Now, the one that we probably should talk about even more is 20. So let me write 20 down here. If I miscopied any of those exponents, let me know. I think they're good, though. My suggestion on 20 is we start the same way of 19. Okay? I'm not going to jump into trying to take square roots or rationalize yet. I'm going to say, can anything divide? Okay? So, does 5 divide by 2? No. So those are going to have to stay under the radicals. X to the 12th over x to the 6th. Can that divide? Yeah, so we could clean up our x's here. Same thing with the y's. So that's going to be my first suggestion. The square root of 5 is going to have to stay on top, and square root of 2 is going to have to stay on bottom because 5 and 2 don't divide. Now, what do we know about x's? In order to do x to the 12th divided by x to the 6th, x to the what?
6.
12 minus 6, which is 6, right? And because there are more x's on top, that x to the 6th is going on top. On bottom, the y's. What about y to the 10th divided by y to the 3rd? That's y to the 10 minus 3, which is y to the 7th. Again, there were more y's on top, so I'm putting that y on top. Now, there are some perfect squares that we can get rid of in the exponents up here. I'm going to save that for a little bit later. What's wrong with the square root of 2? We're not allowed to leave a square root in the denominator, right? So, the whole directions say divide and simplify, rationalize the denominator if necessary. That's where we're at, guys. We need to rationalize. So, in order to rationalize, we're going to multiply by something. How do you get rid of a square root of 2? You multiply by itself, right? So in order to get square root to disappear, you multiply by itself. If we multiply the denominator by square root of 2, we're going to multiply the numerator by square root of 2. Okay. On top, I have the square root of 5, x to the 6th, y to the 7th, times square root of 2. Well, when I multiply those, 2 times 5 is going to be 10. So 10, still x to the 6th, still y to the 7th. On bottom, square root of 2 times square root of 2. 2, right? And you can go ahead and say 2 there if you want. The other option is to say that it is the square root of 4, and the square root of 4 becomes 2, right? I don't care if you go straight to it or if you take that extra step. Okay. Is there anything else I can do to this before I circle my answer and call it quits? Can I divide 10 and 2? Not in this situation because 10's under the square root, 2 is not under square root. Okay, so they're not like pieces. Are there any perfect squares in my variables?
6.
Okay. Are there even variables that I can divide 2 by, right? So I'm going to rewrite this out. 10 is staying 10. I'm going to break it into pieces. X to the 6th, am I going to be able to divide that by 2? Yeah, so I'm just going to leave it as x to the 6th. Y to the 7th, am I going to be able to divide that by 2? Can't divide 7 by 2.
6y.
Closest number below 7 is 6. So y to the 6th, y to the 1st. Still all over 2. Okay, almost there. On top, square root of 10. Can't do it. Stays under the radical. I guess I didn't even address, are there any perfect squares in 10? There's not. Not sure if I addressed that, though I might have skipped over that detail. X to the 6th. Can I take the square root of x to the 6th? Excuse me. Divide by 2, and 6 divided by 2 is x to the 3rd. Y to the 6th. Divide by 2, 6 to the 2 is y to the 3rd. Y to the 1st. Can't do it, it stays under the radical. And don't forget, you still have a 2 in the denominator. Excuse me. Okay. So I wanted to show both of those versions because they're, one you end up having to rationalize, the other you don't, and I think that makes some good examples.
Did you do 50?
50.
50, yeah.
You write down the information for 50. Okay, this is something we did at the end of last week, talking about use composition to determine whether f and g are inverse functions. Okay, technically we could graph these and see if they are reflections across the x-axis, okay, or excuse me, across the y equals x line. But the other way we talked about is checking Fogg and Goff, so composing them and seeing if they equal x. So, first one I'm going to try. We have to do them both to know for sure. But I'm going to look at f composed with g of x, or I more commonly say Fogg. I don't know if all math teachers do that, that's just me, but I know you'll hear Fogg other places. So this is also f of g of x. Okay. F of g of x says we take g and put it into f, correct? So if I'm going to put g and put it into f, then this is going to be f of, what is g? X plus 9 squared. Okay? So that is going to be our new input here. Okay. F of x plus 9 squared says we're going to take f, whatever f is, and we're putting in x plus 9 squared in place of x. Okay, so we're going to take this x plus 9 squared value and we're going to sub it into f. So f says the square root of something minus 9. That's what the f rule says. When we put something in for x, the something I'm putting in is x plus 9 quantity squared, because that was my g. Okay? Now, the key here is that if this is going to equal x, pretty much everything's going to have to cancel out, and that's not going to happen. Okay? I'm trying, how far did I go on the answer key? Okay. If you weren't quite sure here, and here's what I'll tell you. You can take square roots of a single term, but you can't take square roots of multiple terms. Okay? That doesn't work. Those rules don't apply. But if we were to multiply this out, remember, x plus 9 squared is x plus 9 times x plus 9. And so you would have to multiply this out. We can't do the square root of x plus 9 squared is x plus 9 because there's a minus 9 over here. That's the catch we run into. So this ends up being, if we FOIL this, x squared plus 18x plus 81 minus 9. Are we going to be able to clean that up enough to make it equal x? And the answer is no there. And there's no way it's going to clean up enough to be equal to x. So I know at this point, this does not equal x. Technically, and if you can find one of these that does not equal x, we know they're not going to be inverse functions. Okay? So on the answer key, I worked both. But technically, if you're confident in everything you did here, you could stop here and say, oh, it doesn't equal x. I can be done with this problem. They're not going to be inverse functions. I'm going to go ahead real quick and demonstrate the other just for practice. And in case there is any question here. So the other way, g composed with f of x is g of f of x. Okay. So this one says I'm putting f into g. And what is f? F was the square root of x minus 9, right? So that is going to go into the rule for g. Now, the rule for g is x plus 9 squared. So every place I see x, that's where we're going to do that. So we're looking at something plus 9 quantity squared. Except we're putting in square root of x minus 9. Officially, and I'm trying to think, how did I show it? Yeah, officially, you would have to FOIL this out to see what happens. Okay, I'm going to tell you, if you FOIL it out, you're not going to be able to get down to x. But you would have to do, it doesn't look like I wrote this part on the answer key. You would have to FOIL that. Okay. Square root of x minus 9 times square root of x minus 9 is x minus 9. Here you'd have 9 times square root of x minus 9. Here you'd have another 9 square root of x minus 9. And then lastly, 9 times 9, which is 81. Well, it's messy, it's ugly, and most importantly, it does not equal x. Okay? So that's how I know that these two are not inverse functions. Okay. So I don't know which part of that you wanted to see or talk about, but
I was talking about the golf part when we distributed. I was lost there. So.
and it looks like I kind of skipped that line because I was running out of space pretty much. To be honest, that's the reason I probably skipped it. But so this part right here, did that help
Yeah.
then?
That was cute.
Yeah. I promise, it's legitimate. It's not magic. Just looks like it when the teacher didn't put that step on there. Okay. What else should we talk about? Yes.
You did number 35.
35. Okay. 4 times 3 minus x to the 4/3 minus 5 equals 59. Okay, so this is this. I think I put 2 in here. This is in our solving equations group, right? Solving equations, your job is to get the radical by itself, right? So if our job is to get the radical by itself, we don't exactly have a radical, but what we're trying to get by itself is that right there. So we're trying to get those parentheses raised to the 4/3 power by themselves. What do I need to do to make this happen?
You just add the 5, subtract 4.
Add the 5 and what?
Subtract 4.
Not subtract 4.
Distribute it. Now what?
I like divide the 4.
Never would have thought of that, but alright.
Okay. Well, we'll talk about it here in a moment. So start by, since it's a minus 5, we're going to add 5. And so if I add 5 over there, I have 4 times 3 minus x to the 4/3. Minus 5 plus 5 cancels. 59 plus 5 is 64. And then, since we're trying to get this parentheses part by itself, since it's 4 times that, What will undo 4 times something?
Divide.
And that is to divide. If we divide the left by 4, we're dividing the right by 4. The 4's cancel. 3 minus x to the 4/3 is equal to 64 divided by 4 is,
4.
is it 16?
Huh?
16, yes? No? Okay. Okay. Now our, quote, radical, not exactly radical, but same idea, is by itself, right? When it was a power, what did I suggest we do to get rid of the power? We are raising it to the reciprocal power. What's the reciprocal of 4 over 3?
32.
That might be something in a moment, not yet. Reciprocal of 4 over 3 is 3 over 4. If I raise the left to 3 over 4, we're raising the right to 3 over 4. Now, good news, the whole point of this on the left, right? Or correct? What is 4/3 times 3 over 4? 4 over 3 times 3 over 4 is
12 over 12.
12 over 12, which is
3. 1.
about 1. Okay? So this just becomes 3 minus x to the first, or 3 minus x. Now, 16 to the 3/4. Here's what I'm going to suggest. Put 16 under a radical. 3/4. The 4 tells me to take the 4th root, and the 3 tells me to raise it to the power of 3. So what's the 4th root of 16? That's on our blue paper, isn't it? 4th root of 16 is 2. And then we're doing 2 to the 3rd, and 2 to the 3rd is
6.
8. 2 times 2 is 4, times 2 is 8. So then I have the very basic equation, finally, of 3 minus x equals 8. If you...
Plus the x over.
Oh, you're going to plus the x over and go the other way? Okay, you can plus the x over, or what I just started to do was subtract the 3. It doesn't matter. We'll get to the same place. I know. I'm going to fix it. I have a negative x. 8 minus 3 is 5. But if negative x equals positive 5, then
So that's
x equals negative 5. You can get that by just multiplying by negative 1. Okay? No, because you would have still had to move the 8 over, so we did equal steps. Officially, what do you need to do? It's already done on your answer key here, but officially we need to check this. Does negative 5 work in the original problem? Okay, so I have it checked off. I didn't write down my checks because I didn't have enough room there, so I have it checked off that it does. Should I go through that?
Yes.
So, I mean, if I put it in, 3 minus negative 5. 3 minus negative 5 is 8.
Positive.
So it's 4 times 8 to the 4/3 minus 5. And does that equal 59? Well, 8 to the 4/3. That is the cube root of 8 raised to the 4th. What's the cube root of 8?
2.
2. 2 to the 4th? 16. So now we have 4 times 16 minus 5. Does it equal 59? And that's a little obvious, or a little more obvious, that's what I meant to say there. 4 times 16 is 64. Minus 5 is 59. It does check. Now, I'll be honest. The math teacher in me says, that was probably going to work anyways. That probably wasn't going to be a huge issue. The ones that are issues are the ones that are more likely to be issues are either A, when you have two radicals, like 37, or B, when you have an X outside of the radical, like 36. Those are the ones you really want to pay attention to your checking on. Okay? Those are the ones that you're more likely to run into problems. The powers you could, but not as likely. Okay? What else? I was gonna say it's a little late now, I know, but since this is an option too to run this, since we have so many people charging here, you're fine. I'm just, no, it was just a thought, like afterwards, it's like, no one's using that over there. I've done that before where I'll run it to like this row.
That is cheap.
So, it works, I mean. In my smaller classes, it's not an issue. In the bigger classes, yeah. Okay, what else should we look at? What are the hang-ups?
All of it. 36 probably.
What?
36.
36 is one you have to check.
Yeah.
Because there's one of our answers ends up not working. And the reason I know I probably need to check that just by looking at the problem is because there's an X outside the radical. That's where I'm going to likely see that we need a check. So, are you wanting to go over something like 36? Or
It's just the same process.
it is the same process. You do have a FOIL in 36 that you have to do. So it makes it a little bit more complicated, but I can do it, I cannot. It doesn't matter to me, so.
What do you think, Josh? 36, everyone? 36? We'll go with 36, guys?
If you didn't do 36.
I'm on 20. That's crazy. That's what I'm on too. Aaron, look at that. It's on.
We'll do 36, why not?
Aaron, look, it's on 23. You're so far.
Okay. 36. Yeah, to say you're on 2, on 20, on 50, doesn't really mean anything because does everyone go in the order?
No.
No.
I do.
Some people do not, some people do, so. There's some people that started on 50 on Friday because that was freshest in their head, right? Okay, 36. 36 is technically the second half of the chapter. Similar to the last one. This one has an actual radical. When you see a radical, your job is to get the radical.
Right line.
How about by itself? So if I'm going to get this by itself, what do I need to move away of the radical? Or move away from the radical? The -8. If I'm going to move the -8, I'm going to add the 8. So then I have square root of 3x plus 28 equals x plus 8. Radical is by itself. What's my next step? Take both sides and not square root it,
Cube it. Square it.
square it. It is a square root, so we're going to square it. If I square the left, we're going to square the right. On the left, what happens when you square a square root?
It cancels.
So we're going to have
3x equals 28.
on the right. What about x plus 8 quantity squared?
X squared plus 6.
More than that. We do need to FOIL this. I know, that pesky FOIL. X times x is x squared. X times 8, 8x. 8 times x,
8x.
8x. 8 times 8,
64.
64. If you go ahead and clean that up, some of you may have already done that, but it is x squared plus 16x plus 64.
We're using green and purple. It looks like the hog.
Looks like what?
The hog.
Okay. So carrying down that 3x plus 28 on the left, I've got my FOILed response on the right. Okay, guys, what's my solving step here? Yeah. We need to be, there is an x squared, there's an x, and there's a constant. So x squared, x, and constant means we're hoping it's going to factor. We need to make the equation equal to 0. So in order to move this, I'm going to keep my x squared positive. That's how I like to do this. So to move a positive 3x, I'm subtracting 3x. To move a positive 28, I'm subtracting 28. Okay? Got it. So on the right, or on the left, excuse me, those cancel. I have 0. On the right, x squared, 16x minus 3x, 13x, 64 minus 28, 36 maybe, if I did my math right.
Yes, it is.
Okay. Does this factor?
Yeah.
X squared breaks up into x and x. I need numbers that multiply to be 36 and add to be 13. What multiplies to be 36 and adds to be 13? 4, 9. Everything's positive, so we put positives in. What are my possible answers here? Said x plus 4 equal to 0 and x plus 9 equal to 0. Possible answers are -4 and -9. What must you do here?
Check them.
You must check. And here's my clue that there is a high likelihood that something's not going to work. And that's because I have a square root and I have an x outside of that square root. Okay? It is very likely something won't work. Not guaranteed, but likely. So, square root of 3 times -4 plus 28 minus 8 equals -4. This is me plugging in -4. So -12 plus 28 is 16. The square root of 16 is 4. 4 minus 8 is -4. So -4 appears to work. I would also check -9 to be safe. 3 times -9 plus 28 minus 8 equals -9. -27 plus 28 under the radical is going to be square root of 1. Square root of 1 is 1. And we have 1 minus 8. 1 minus 8 is -7. Does -7 equal -9? It does not. So -9 does not work there. Again, you don't have to write down the check. Okay? I am 100% okay with you guys doing that check in your head. However, are there times it helps? There are. There's times it helps me if I write it out. Okay? So, varies from person to person. Okay. Where are we at on time?
We're checking.
Okay. Is there anything else you want to talk about real quick?
How are you in that?
Okay. A couple reminders. First of all, is your Savas caught up? Is your IXL caught up? If they're not, get those caught up. Okay. Review worksheet will be due on Wednesday when you walk in for the test. So make sure you have it done. The review worksheet is your study guide, right? If it's on the review worksheet, it could be on the test.
I got